All right, this letter is from Pre-Calculus 30, I think section 3.2 in the course that we're on right now, but this is talking about the remainder theorem. Okay, so how do you find the remainder when you either do polynomial long division or synthetic division, which we've learned how to do? How's a quick way to find this remainder? And actually there is a bit of a trick. So I'm going to fill in some blanks here for you. In this chart, we have an original polynomial, and we have a number of different divisors, binomial divisors. And so what we're going to do is we're going to identify what the a value is in each of these. If you remember how to do that, the format is x minus a. Oh, I guess it's right here. And so really, this is x minus what? Well, it's x minus a positive 3. This is x minus a positive 2. X minus 1. And this is x minus a negative 1. So we just flip the sign of whatever operation is in here, okay? And so that's the value of a for each of those. Now, this table over here, okay, so if we divide this by this, we get this is a quotient and this is a remainder. So they've just kind of done some work for you. And they're asking you to basically determine what the pattern is here when you substitute x equals a into the original polynomial. And so that's really this, p of a, the polynomial that you're given with a included. So over here, so let's take the first one, 3. So p of 3 is going to be 3 cubed plus 2x squared, minus plus 3 squared, I'm substituting, 3 squared minus 5 times 3 minus 6, correct? So this is 27 plus 18 minus 15 minus 6. If you do all that algebra, you should get an answer of 24, which actually is the same as the remainder. And you guessed it, if you continue this along, and let's do this one right here. So I'm going to plug now, p of 1, so that's the a value. What do I get? Well, this is what I get. And when I fill that in, p of 1 is negative 8, the same as this. Okay, so what does that tell us? It tells us that the remainder theorem says that if you substitute x equals a into the original polynomial, you will always get the remainder when you divide by the binomial that is x minus a. So I'm just going to write that out for you so you can read that, and that's the remainder theorem. So when it's all said and done, the remainder theorem is this. When dividing a polynomial that's p of x by a binomial in the form of x minus a, the remainder of that division is represented by p of a. So that is when you substitute a into the original polynomial. So remainder theorem, just remember that p of a equals the remainder what you would get in long division or in synthetic division.
Okay, thank you.